Hi there, it's Mrs. Marquette here with 8.5 for you, properties of logarithms. Get excited. Remember from last time, when dealing with logarithms, we're really dealing with a new way of writing exponents. The mantra that we're going to have and already have had is logs equal exponents. Say it with me, logs equal exponents. And one more time, logs equal exponents. So when I'm doing this warm-up, I want you to do exactly that. Tell me what exponent for each of these, or what exponent are these logs equal to for each of these. So log base 5 of 25. So this means the power that makes 5 to the power 25. Okay, so that's that one piece. That first one, that question mark is 2. Okay, so this is kind of like scratch work. I can put that over to the side. And then I want to know what the second one is equal to. So this is like 5 to what power gives me 125. Okay, we know that that is 3. Again, this is scratch work, so I can put it off toward the side. So if I just look at my simple math problem, 2 plus 3 is equal to 5. You might be thinking, well, that seems like a silly way to write 2 plus 3 equals 5, or the number 5. But remember, we're just looking at exponents, so it makes sense that our exponents are smaller. So when we add those exponents together, they end up being also a pretty relatively small number. If you want to pause the video and try the rest of them, you can already, or if you want to watch one more with me, that's fine. I've got log base 5 of 125 minus log base 5 of 25. Remember that we said that this was 5 to what power gives me 125. Okay, that's like one number. What is the exponent there? That's 3. And then minus, what is the exponent there? 5 to what power, because logs equal exponents, equals 25. That is 2. So 3 minus 2 is just 1. So our answer is just the number 1. Okay, the next one, log base 5 of 25 squared. So I can think kind of like of this as one problem. So what is log base 5 of 25? We've already kind of said that the log base 5 of 25 is 2. So because 5 to the second power is 25. So I can say 2 squared is 4. And finally, I've got 2 times the log base 5 of 25. We already said that this is 2, so 2 times 2 is also 4. Kind of nifty that those last two are the same. We're going to see that that is actually not a coincidence at all. So let's check this out. Properties of logarithms. We're going to be using these properties all day today, so I'm going to kind of run through them a little bit slowly. Log base b of m times n, so when these letters, these variables are written next to each other, remember that that means multiplication, then I can actually split these up. I can say the log base b of m, so I've written log once, and then I can say plus the log base b of n. Okay, so the couple things to notice. First, multiplying is going to be matched with adding, and when I split it up, I have 2 logs instead of 1. So I have like 1 for each of those pieces, m and n. What this is related to is if I have a to the m times a to the n, so if I've got like the same base in different powers, remember what I do with those powers is I add them together. Okay, so this is like x squared x to the 5th is x to the 7th. This makes sense to us, I should say, because logs equal exponents. So logs should also act like exponents do because they're just another way to write them. So if I'm multiplying, I can kind of relate that with adding. The next one is division. I have log base b m over n, so this is divided. Okay, that's division. Then I can write log twice, so log base b with m, log base b with n, but the way I split it up this time is subtraction. Think about why that makes sense with exponents. If I have a to the m over a to the n, I take those powers and I subtract them, m minus n. Or think 7 over x squared. This is x to the 5th. I take 7 minus 2, or I go to battle. So again, logs are exponents. They equal exponents. So they should also act the way that exponents do. And the last one, this is kind of, I think, the trickiest one. Log base b of n to the y. I can take this power, and I can kind of put that out front and multiply. So it's y times log base b of n. Okay, so again, notice log base b and n, that piece stays exactly as it was. It's the power that comes down. The related rule here is if I have a to the m raised to the n, I multiply those powers. So if I have x to 5, then this becomes x to the 10th. So think that really is what's happening over on the left. I have a y as a power, so I want to multiply it to another exponent because logs equal exponents. That's what they are. So it's like a power times a power. Okay. So these will be on your guide, these properties, but you've kind of got to know what they mean. So you've got to know that this is multiplication and it matches addition, that this is division, so I'll put multiplication, division, and then that this is my power rule. We also are going to have to be able to go forward and backwards on this rule, or on these rules. So I can start and I can finish with 2 logs, or I can start with 2 logs and go backwards and end at my 1 log. So you have to know which side you're starting on. So if I want to expand the expressions, that means that I'm starting over on the left side. So with these pieces. And I want to get to a more expanded out version. So I have log base 6 of x and y. So the first thing I want to know is, am I doing the multiplication, the division, or the power rule? These two are multiply. Multiplying goes with adding. So I've got 2 pieces. I've got the x and the y. So I'm also going to write my log twice. So log base 6 and log base 6. Each of those terms, each of the x and y, get its own log. So I can say x and y, and since it's multiplying, I match it with adding. Okay. And that's really all I'm doing for the first one. So if I want to actually make it a little more closely grouped together, that's fine. This is my final answer. Number 2, log base 7 of m and p. What I'm going to do is think, okay, I've got how many pieces in my argument, m and p? There's 2, m, p, so I'm going to write log base 7 twice. Log base 7, log base 7. M gets one of those, p gets one of those. And then since it's division, it's going to go with subtraction. So I put a minus in the middle. So I've got log base 7 of m, log base 7 of p. And again, I can write it closer to each other if it makes it a little neater for us. And this last one, this looks like I have a power. So in the power rule, what I do is I take this exponent and I make it a coefficient. So I'm going to say instead 2 log base 4 of 7. There's not really much I can do with that because I don't know what log base 4 of 7 is, like 4 to some power. It's not a nice number, so I'm going to have to wait on that. Okay, so I'm going to keep doing these. If at any point you feel like you want to pause and see if you can do these yourself and then fast forward, that's absolutely fine with me. But I'm going to start on number 4. I've got log base 10, and then I've got x, y, and z. I have really 3 pieces here. So the number of times I'm going to write log 10 is 3. Log 10, log 10, log 10. Each piece gets its own piece of its own log. So x, y, z. Notice that 10 is small and our x, y's, and z's are larger. Since each of these are multiplying, I'm going to put adding in between because multiplying goes with adding. So I've got log x plus log y plus log z. Remember that technically that's 10 is a common log, so if you would rather do log x plus log y plus log z, that's fine with me too. Number 5, log base 2, 7x cubed over y. There's actually a lot going on here. I can put a multiplication symbol here, division symbol there. So there's really like one piece, two pieces, three major pieces going on because that 3 is attached to the x. So I'm going to write log base 3 or log base 2 3 different times. So the 7 gets 1, the x cubed gets 1, and so does the y. And between the 7 and the x, those two are multiplied, so I'm going to put a plus. The division sign becomes a subtraction. And then what I still have to deal with is this power. The power can come out front. So I've got log base 2 of 7 plus 3 log base 2 of x minus log base 2 of y. And that's my final answer. You are only done when you have no more powers and all of your terms only have one piece each. So your log base 2 has a 7, log base 2 has an x, log base 2 has a y. Here, see if you can think of how many pieces it has. Okay, I've got 2, so I'm going to write log base 5, log base 5. The 2 gets its own, and the x to the 6 gets its own. Maybe you even notice that this 6 is really an exponent, so it can be a coefficient. Since I've got multiplication, I can expand with an addition sign. And the last ones, this number 3, there's another number 3. This one's a little tricky because of this square root, but the main thing to remember is another way to write a square root is with a power. So I can write 2x to the 1/2, and then notice that this is a power, okay? So that power can come out front. So I'll have 1/2 log base 2 of 2x. And this log base 2, 2x, I've got to think log base 2 of 2 plus log base 2 of x. And log base 2 of 2, that's 2 to what power gives me 2? This one actually works out nicely. This becomes 1 plus log base 2 of x. I can leave it this way, or I can distribute that 1/2. So 1/2 times 1 is 1/2 plus 1/2 log base 2 of x. So I would say that number 3 is probably the hardest one on this part of the notes. So if you want to take a second to re-look at that one, that's a good one to check out. This one I think you should be able to do. In fact, it's very, very similar to number 1 and number 6 put together. Okay, so maybe pause the video and try this. But this is log x plus 2 log y. Think, since this is multiplication, I write my log twice, and I'm combining with a plus. My 2 had to go in front of my log y. Notice on this one, I don't have parentheses around my x and y, so the 2 doesn't go to each piece, it just goes with the y. Whereas on this one, my 1/2 was around the entire 2x, so I could kind of look at that first before splitting it up. So that's expanding. I'm taking one log and I'm making it many logs. Condensing is the exact opposite. I'm going to have many logs and turn it into one log. Okay, so on number 5, I have log written 3 different times. My goal is to be writing log just once. So I'm going to write log and then leave space for my argument. The first thing that I can look at is, do I have any coefficients? Because the power rule is going to be the biggest thing to look at first. So this 2 is actually going to become a 2 on my argument, on my 2. So this 6, I'm going to multiply by 2 squared. And then the minus becomes a division symbol, so I do divide it by 3. Okay, we could have actually done this in 2 steps, so it might help if I did this. Log base 10, so there's no base. Log 6 plus log 2 squared minus log of 3, and then I could have combined together. So I've got 6 times 2 squared over 3. I can simplify that. When I do simplify that, I get log 6 times 4 is 24, divided by 3 is just 8. So log of 8 is my final answer. So you can see that actually that looks like a nicer thing to put into our calculator. You could actually plug that straight into your calculator and get a real answer. Number 6, the first thing we should do is probably move up these coefficients to be exponents. So let's do that first, and then we'll combine everything. So this would be log base 3 of 7 squared minus log base 3 of z to the 5th. Okay, my goal with condensing is I just want to write log once, and then everything else can be an argument. So I zoom in on this minus. Minus relates with division. So I'll have 7 squared, which is 49, and then z to the 5th on the bottom. Notice that I have a 3 and a 3 on my base, so I should also have a 3 for my base for my final answer. You can only combine logs if they have the exact same base, so always double check that. On number 5, they all were just log, log, log. Number 6, I had a log base 3. So looking at number 7, I have a log and a log again. You could write log 10 if it makes more sense to you. So let's move up coefficients first, and then we'll put everything together. So log, I can say base 10 of x to the 1/2 minus log base 10 of 4. That minus is going to be division, but not until I make this just 1 log base 10. So I'll have x to the 1/2 over 4. If I wanted to, I could write that 1/2 power as a square root, but I'm fine with your answer just like this, with or without the base 10. And then I have log base 4 of 5 plus log base 4 of x plus log base 4 of y. I have no coefficients to bring up. They're all 1s. So I'm just really going to write log once, and it's all log base 4, and then decide how everything is related together. Since it's a plus, and a plus, I am just multiplying. So 5 times x times y. And that is my final answer. Okay, so condensing, again, I'm taking many logs, and I'm not done until I have my log written only one time. The last thing that we're going to do today is something that we do in our calculator. It's called the change of base formula. This is a way to change logs into something that I can plug into the calculator. So this is true for any base. I've got log base b of x is equal to log base a of x over log base b. The only thing that matters here is that a matches a. So this would work for any number, but the numbers that our calculator knows is they know how to work with just log base 10, or they know how to work with the natural log, log base b. So those are the ones that I have actual buttons for. So this is helpful for us because I can write any log as log x, so log of the thing on top, or the argument over log base b. I usually think of the x, the larger thing, looks like it's more above, so that's the thing that goes in the numerator, and then log base b is in the denominator. This is on your guide, but you have to know how to use it. You have to know to plug in log x over log b, or you could use the natural log. Either one is fine. So I'm going to flip onto the calculator. So if I'm going to evaluate the expression log base 3 of 7, so the 3 is the little number, the 7 is the big number on your notes, what I'm actually going to do in my calculator is do log of 7, so the number, the argument, divided by our log of our base. The main thing I want to stress is that you have to do log both times. Okay, so log 7 divided by log 3, hit enter. And they ask us to evaluate to 3 decimal places. So this is 1.771. Number 10, log base 6 of 15. I'm going to do this with log, and then I'm also going to use natural log. So I'll do log 15, and then I'll divide by our log of our base, log 6. Please close your parentheses on both of your numbers, otherwise you'll get wrong answers. And we get 1.511. You can do the exact same thing with natural log. Natural log of 15 divided by your natural log of 6. Hit enter, and you get the exact same number. The last 2 problems, log base 2 of 5, I do log 5, close the parenthesis, divided by log 2. Again, don't forget to close your parenthesis before you hit enter. And you get 2.322. Remember, rounding to that 3rd decimal place, I look at this number, I take the 9, and I round up. And then 12, I've got log base 7 of 10. I do log of 10, because that's the argument, divided by the log of your base, which is 7. Notice I close the parentheses both times, hit enter. And I get 1.183. The final thing they want us to do with this is to actually use these properties to evaluate. So if I look at number 13, I've got log base 3 of 3 times 9. Okay, so this, I've got my multiplication sign, which means I'm going to be using the multiplication property. So I'll tell you log base 3 twice because there are 2 pieces. Log base 3 of 3, log base 3 of 9, and then I'm adding them together. The reason that we break these up is because log base 3 of 3 and log base 3 of 9 are much nicer to evaluate. I can say 3 to what power is 3? That is 1. 3 to what power is 9? That's 2. So my answer is 3. So if I actually did log base 3 of 3 times 9, I would have gotten 3, but by breaking it up, I just make 2 really simple problems for myself. 14, I've got log base 2 of 4 to the 5th. 4 to the 5th is going to be a really big number, something that's more difficult to work with. But if I remember that my power property says that that 5 can become a coefficient, I do 5 log base 2 of 4. So this is 5 times some number that is an exponent because logs equal exponents. I've got 5, and then 2 to what power gives me 4 is 2. So I get 5 times 2 is 10. Okay, that's my final answer. Log base 3 of 1/3. If you don't know that one off the top of your head, notice that this is the division property. I do log base 3 twice. So I've got 1 and 3. And since it's division, I put a minus in the middle. So 3 to what power is 1? We know that that is always 0. And then log base 3 of 3 is 1. So I get -1. And if you think about it, 3 to the -1 power, and negative power flips your fraction. So that makes sense. And then number 16, I've got a 3 in my exponent. That can become a coefficient. I get log base 5 of 1/5, but 3 is my coefficient. And then that 3 can actually be multiplied by this division power. I've got log base 5, 1, and 5 with a minus in the middle. So I get 3 times 0 minus 1. Notice it's set up very, very similarly to the last problem. I get 0 from 5 to what power gives me 1. I get 1 from 5 to what power gives me 5. So I get 3 times -1 is just -3, which would actually make sense for us as well here because I'd have 1/5 2 would be 5 to the negative 1, and then to the 3. So I'd have just negative 3 as my answer. So what we learned today is we looked at expanding and condensing logs using these 3 properties. So those are 3 properties that you have to get comfortable with through some practice problems. And then we also learned the change of base formula, plugging things into your calculator. This is super helpful for you for quizzes and tests, but only if you know how to use it. So please make sure that you are looking at the guide while you're doing your practice problems. I will see you later.